I'm Mathew Becker. I'm a senior aerospace engineer at the Pennsylvania State University. I'm working with the Student Space Programs Lab as the Osiris Mechanical Subsystem Engineer. So the first project I worked on for the SSPL was NITNI-SAT, which was an entry into the NanoSat 5 competition. It was about this large, square, and it was doing ionospheric research. It had several antennas on it, and I was working on the antenna deployment system that would deploy those antennas in orbit. Another project I ended up working on that freshman year was the Cansack Competition, which was this guy right here. It's significantly smaller, going down from about several feet to a side down to just about 3 inches. It has to fit about a Pringles can. So much smaller, much more packed full of everything. So there was fun challenges for that in freshman year. This guy had to go or launch in a rocket up to about 4,000 or 5,000 feet and parachute down. And once it landed, have to upright itself, which is the purpose for these legs right here, and then measure the ground temperature and take a picture of the surroundings. So that one we ended up launching the summer after my freshman year. Then in the following fall, instead of returning for my sophomore year, I took an internship with with NOSROC, a sounding rocket contract in Wallops Island, Virginia. They worked on these large sounding rockets, we're up to typically around 30, 40, 50 feet tall, that would go into the upper atmosphere to do various different types of studies, whether it's telescopes or other things like that. I got to do some optimization with the lanyard switch, so each one of these rockets would have anywhere from 4 to 10 of these switches that would confirm at launch, and they were really expensive to make and time consuming, and one of my projects there was to make them significantly cheaper and easier to mass produce for the rockets. And then I also got a chance to work on different type of machining projects and testing on the rockets and get my hands in all sorts of places there. So after that internship, I returned back to Penn State for the spring, and I started working on the Osiris-Lite project, which was a technology demonstration of our CubeSat bus that we wanted to work on and propose to National Science Foundation. It was pretty simple mechanically, but it was a definite step forward towards getting a reliable CubeSat system. And during the next year, we'd end up improving that and making it even better. So the next summer, I got to fly over to California to work at the NASA Jet Propulsion Lab facility outside of Los Angeles. There, I got to work on the Mars Science Laboratory, the next rover, the next Mars rover. I got to do a bunch of different testing, help out with that. So that one I really got hands-on experience on how you can certify these types of engineering payloads and make sure that they're going to meet the requirements after they've been built. This guy here is Osiris-Lite 2, a revisit to the last year's Osiris-Lite project. I worked on this my junior year. This one we tried to take everything we did in Osiris-Lite 1 and bring it down into the CubeSat form factor, which is this guy right up on the top here. Much more challenging, much smaller space. This is only about 4 inches to the side, so all the borders had to shrink down. All the wiring had to be neater and tighter, and everything was more compact. And we even had to fit more things on here, like these antennas up here. Everything else down here was just for everything that wouldn't be on the satellite, but we needed for integration on the high altitude balloon. So this summer I'm staying up at Penn State to work in the Adverse Environment Rotor Test Stand. It's a test facility for rotorcraft blades built in a freezer to study how icing accumulates on rotor blades and developing systems that eliminate or minimize that icing. So one of my reasons for deciding to work up here over the summer was I wanted to branch out and try to experience different types of things. Up through my junior year, everything I've worked on was pretty much space systems, rockets, things of that sort. And I wanted to get a chance to try helicopters, airplanes, stuff like that, and get outside of that space field. The rotorcraft lab is giving me a chance to branch away from the mechanical systems of spacecraft and into something more earthly. Although, even though there are differences, a lot of the stuff I've learned in the past 3 years can still readily be applied. The engineering process is just exactly the same. Still go through, investigate the problem, figure out what you need to do, and do all the designs and analysis necessary. So no changes there, and that can be applied not just to aerospace engineering, but pretty much everything. All the software is pretty much the same, or at least similar enough that once you learn one type, you can easily pick up everything else without too much difficulty. You just got to figure out where the other buttons are. A lot of the projects we work on in the rotorcraft lab involve de-icing systems, and many of those require systems being built inside the airfoils themselves and the rotor blades. So that's where working on all these small projects like the Osiris CubeSat or the Cansack has come into play. I'm so used to working in small areas that are less than a few inches, and while helicopters are much larger, I'm still working on the small components that have to fit inside those blades. So being comfortable with that's a great advantage there. Keeping track of the wiring within the airfoil, I've gotten pretty good at, just from how many times I've had to do that in the projects for the SSPL through the CubeSat, the Cansack, and NISAT, all those other different projects. Wiring was always pretty tight. One of the things I've learned in the past 3 years that can be applied to any type of engineering or any type of business in general is how to convey information to others and how to keep track of that information. So whether it's just how to make an effective PowerPoint, to how to write everything down in a way that anyone can read it and know exactly how much you know about the subject, to just how to draw a sketch that accurately conveys what you see in your mind so that they can see it as well. So one of the benefits of working in the Student Space Programs Lab and these various internships I've done over the past few years is that by the time I graduate and go into industry, I already know a bit about what I'm going to get myself into, and even if it's something outside the fields that I've been working with that I'm comfortable with, I can apply the things I've learned through these programs to help in the learning process that I'll need to go through in those new fields.